Okay, let's go ahead and solve the warm-up. If you remembered last week, I encouraged you to commit this to memory, and I asked you to memorize 2 to the third power is equal to 8. And here's an example where we're going to use that. If you remember, we said that exponents is repeated multiplication, and we broke these exponent forms of our numbers into two pieces. We said the base and then the exponent. The base is the number that's being repeatedly multiplied, and the exponent is telling you how many times to repeatedly multiply that number. So we said, okay, 2 is on repeat, and we said that it's on repeat 3 times, so we wrote 3 blanks, and then we put our multiplication symbol in between, and we put the number 2 that's on repeat in each blank, and then we multiplied each factor and found the answer. 2 times 2 is 4. We brought the rest of the equation down, the rest of the expression down, and 4 times 2 is equal to 8. So we're going to do the same thing with 3 times to the third power, and we would do the same thing here. We would say that we have the number 3 on repeat 3 times it's repeatedly multiplied. So we'd have 3 blanks, and I'm going to use a multiplication sign here because it messes up when I try to make it dots. So we're going to say 3 is on repeat, so it's repeatedly multiplied 3 times. So if we start multiplying each factor together, 3 times 3 is 9, bring the rest of it down. 9 times 3 is 27, so 3 to the third power is equal to 27. Let's move on to the next part of this unit. We want to talk about Unit 7, which is equations and inequalities. One of the concepts we need to understand is combining like terms. And the definition of a term is this. A term is a number or a variable in an expression. So the example here gives us an expression. It says x plus 5. X would be x would be a term of the expression, and 5 would also be a term of the expression. And terms can be like each other. So for example, if we look at this expression, we see that there are 4 terms. There's 1, 2, 3, 4 terms. There's 4 terms, and now we can find the terms that are like each other. The 2x and the x both include the variable x, so those can be brought together as like terms. And then we have the number 4 and the number -7, so those can be brought together and considered like terms. Now, we're going to talk about how to combine them, but basically that just means that we're going to be adding them together. So let's talk about what this is going to look like. So if we look at this slide, we can see different sized tiles, and these are similar to the tiles we used when we were adding and subtracting positive and negative integers. So if you notice, we have the positive ones or the unit tiles here, and then a negative unit tile here. But if you notice, these are all different size tiles. If you notice, the colors are different too, but the colors represent whether the tile is positive or negative. So if we look at these tiles, the smaller tiles or the small squares tiles, if you hit your select tool in your fluid math file and drag the box beside it, you'll see the definition for this. And this is what we already know, which is the unit tile. and drag that box away for the larger rectangle, and you'll see that this is what we're going to call the X tile. So the X tile represents a variable, and remember, a variable is going to represent a number. We just don't know what the number is yet. So if we look at this example, tiles that are the same size and the same shape can be brought together. So for example, if you look on the left, you can see where we can bring all those tiles together and we can combine them to find the value of what's being represented here. And we want to remember how to use zero pairs to find those values, because if you remember, a positive and a negative of the same number, when combined, equals 0. They cancel each other out. So for example, the value for the left model would be, let's see, a positive and a negative goes to 0, positive negative is 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 0. So that's going to leave us with 2 positive units. And we can do the same thing with our X tiles because they're the same shape and the same size. So we can use a positive X and a negative X, and those cancel each other out because that equals a 0 pair. We just don't know what the magnitude of the value is, but we do know that the positive of any number combined with the negative of that same number must equal 0. So if we look at the value of this model, we can see a positive and negative is going to go to 0, so those go away, and a positive and a negative goes away. Positive and a negative goes to 0. That's going to leave us with negative X plus negative X, which is repeated addition, which is the same thing as multiplication. We put the negative sign in the front, so that's going to be equal to negative 2x's. So remember, the unit tiles and the X tiles work the same way. As long as you have the positive and the negative, you can create a 0 pair with the like terms. Now, sometimes your X tiles, or the tiles that represent the variables, they might look something like this, where they are the larger tiles, the larger rectangles with a positive or negative, or they might be they might look like this, where they actually have the variable and whether it's positive or negative labeled directly on them. So let's look at these models and let's write an expression for each of these models. So for example, we can look at this first one that's in the upper left corner, and we can see that we have a single X tile, and we're going to add that to a single unit tile. So that expression would be represented as X plus 1. If we look at the one just below it, you can see that we have 2 positives, and we're going to combine that with 3 negatives, and that is going to be equal to negative 1, and we can use our 0 pairs to calculate the value. We have a positive and a negative goes to 0, positive negative goes to 0. That's going to leave us with negative 1, so that's going to be our answer. Then we're going to go to this one right here, and we're going to say, okay, we have X plus X, so we have X plus X. Now remember, X plus X, that's repeated addition, so that's really 2 times X. So we have X 2 times, and then we're going to add a negative x because we have a negative one time. So what is that going to equal? Well, if we use the zero pair skill, a positive and a negative is going to cancel out, and that's going to leave us with one positive x. Okay, so how about this one? All right, well, we have one x tile. We're going to combine that with two positive units, and we're going to add that or combine it with one negative unit. We're going to combine our like terms, which would be the positive 2 and the negative 1 because they're the same shape and same size. So we're going to say a positive and a negative goes to 0, and that's going to leave one single unit. So this is going to simplify to become x plus one single unit. So how would we use algebra tiles to help us model this expression? If we're given the expression and we have to use a model to help us solve. So let's figure out what we have here. And we have 3 x's. So that means we have to have 3 positive x's. And we know that this is going to be a positive x, and a positive x. And then we're going to add one positive unit. And that would be how we would model this expression. We would say we have x plus x plus x plus 1 unit. Combine the like terms. We have x 3 times, and then bring the rest of it down, and that matches our original expression. Okay, so let's take a full example where we actually start with the model. So they give us the tiles, and we need to write the expression and solve the expression or simplify. So we're going to look again, and we're going to say, okay, we have x plus x plus x here. So that's the same thing as saying x 3 times. So we have 3x, and then we have 1 negative x. So we say minus plus negative x, and then we're combining that with 3 negatives. So if we combine our like terms, and we use the zero value strategy, we can say a positive x and a negative x goes to 0, so that's going to leave us with 2 positive x's. So our expression is going to be 2x. This equals 2x. We have 3 positive x's, and we take away 1 x. That leaves us with 2 x's, and then we're going to add 3 negatives. And you could also remember that adding the opposite, if you remember our little strategy, is the same thing as subtracting. So 2x minus 3 would be the expression. Sorry about that. Okay, so for this particular slide, what we want to do is we want to say, okay, here's our model. What is the expression, and how are we going to simplify it? Now I'm going to do all of that in here to utilize this right here. So we have x, we have x plus x plus x plus, now we can go ahead and combine all of our yellows. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 single positive units and 1, 2, 3 negative units. And now we're going to simplify by combining like terms. So our like terms would be here and here, because these are our constant values and these are our values that have variables. So we have x 3 times because repeated addition is multiplication. And if we combine 10 positives with 3 negatives, if you remember the rule, if they're different signs, we subtract. 10 minus 3 is 7, and we keep the sign of the one that's the farthest from 0. 10 we have more positives than negatives, so it's going to be positive 7. If we wanted to go ahead and use our zero pair strategy for the units, we would say a positive negative goes to 0, cancels each other out. A positive and a negative cancels each other out. Positive and a negative cancel out, and that's going to leave us with 1, 2, 3, 4, 5, 6, 7 single units. And that would be our simplified expression. Okay,